Cool. All right. If you can take your seats, please. We're going to start. So our next speaker is Maciej Dąbrowski from Alto Cloud, or I've heard actually there's a name, a change there. So probably you can introduce us to what's happening at the moment. But Maciej is a chief data scientist coming from Galway in Ireland. And he'll be talking about ML in production, right? How to make it successful. I guess I got that right.
In products, yeah, exactly.
Okay.
Thank you very much for introduction, Grzegorz. So my name is Maciej, and I came through data science, essentially through the data engineering / core computer science path. So many years ago, I went through, distributed systems, computer science course, and then done a couple of different things after that. So I really like and enjoy talking about technology. I've been doing Spark in production for 4.5 years now. Started with very early versions doing streaming, so it's kind of fun. Use things like Cassandra and Kafka and all of that. But when I was thinking about this talk, I thought I'll do something a bit different because we've heard a lot of talks today about scaling out from Will. We heard about automating training from the 9 Lives data guys. We heard about the tools, R, different tools, how to actually do data science and so on. But I especially, one thing kind of in my head resonates very well with what Anthony said in the morning was that we are technically in an AI spring. And we still have a lot to get done before we can, enable Skynet and look at robots roaming our streets, essentially. But before we get to the general AI, right? And one important element there is that has always been on my mind over the last number of years was, it's amazing and fun to build algorithms. It's amazing and fun to try out new tools. But the real value is actually shown through how you build a product around it, right? So how do you productionize your code, AI or ML code, whatever you think about that, how you design it to solve the right problem, right? So this is what this talk is about. It will be fairly high level. I will try to show some experiences from the research we've done. If I have time, I'll show you one of our products that we worked on. And hopefully you will enjoy it. And of course, I'm available after for more questions and conversation. So to give you a bit background about myself, so I started, as I said, computer science and machine learning, core machine learning, many years ago. I've done some work in business. I just got a degree in business essentially, and then I went to academia for a number of years, doing research on decision support. And I really enjoyed it because it was the first time I realized sometimes it's not always about accuracy of your algorithm. It's more about how do you actually wrap it into a product and how do you impact your users? How do you relate to what the user is thinking, also the real needs? For example, if you build a recommender system, so how can you make these users to make better decisions, to live a happier lives and all of that, right? And this is the part I'll be trying to address here during this talk. So to give you a bit of background to my recent adventures, let's say, about 4 years ago, I left academia and I joined a startup called Alto Cloud. It was very interesting last 4 years because we focused on essentially building something called journey analytics, which essentially means we collect a lot of data from different channels, like the web traffic. Think of us as a company that you would use similar way to Google Analytics, right? You would drop a snippet of code on your website as a business, and we would start collecting data about the page views, form fills, searches, and so on of your customers. And then, if you tell us what are the important things, like for example, purchasing if you're e-commerce or abandoning shopping cart, or maybe some signups for trial, we would build a lot of different predictive models overnight in the batch process and deploy those hundreds of models in real time to essentially allow to reach out to the customer while they are still on the website. So instead of you getting an email, after an hour of abandoning the shopping cart, before you do that, and the model says, hey, this person is very likely to do that, we will just give you a super deal so that you can convert while you're there. So that was the idea. And to do that, we built a platform using Spark and Cassandra and Kafka in short. That processed a couple of billion events over the last few months. And 2 years ago, we got to change our name from Alto Cloud to Genesis. And to be very honest with you, I have never heard the name Genesis before, and it's a shame because these guys are really good. They are the market leader for customer experience, an amazing company, over 10,000 customers. There's a very high chance if you pick up a phone and call any of the businesses out there, like, I don't know, Nike or you know, airlines, banks, and so on, you'll be actually using our software. This is a primarily, let's say, call center company, but this is much more than that, right? Because it's about the customer experience across channels. So this is the web, the CRMs. It's also the call center, of course. So what was interesting there, because they have so many customers, or we have so many customers, are so successful, you can imagine that one thing we have a lot of is data, right? We have a lot of data from different corners of the spectrum, let's say, and that's the very important, interesting thing, because data is the key, and I'll try to highlight that a couple of times during this talk. But if you ever have done any serious data science in production, one of the things that is always a problem is how to get your hands on the right data to solve the problem you're trying to. And the second thing that's very, very interesting to myself is that with those numbers of customers, what comes with that essentially for free is breadth of use cases, right? So you can think of predictive routing, you can think of managing interaction through chatbots, dialogue engines, you can think of optimization problems, how to staff the call center, how to build models that predict customer behavior, and so on. So there's a lot to get done, and we have to do it at scale. So that's, and I'm here to tell you a bit about this experience as well. Okay. So why is building machine learning products hard? Why do you think it is the case? I think it is hard. Maybe you disagree, but any hints, any ideas why it's hard? You need to have data. Well, I'll give you a hint there, so that's definitely it. But there are a couple of perspectives. One perspective I really resonate a lot with is from Google, actually. I don't know if you have seen that before, but a couple of years ago now, they published a paper when they essentially said, building ML product is fun, but actually ML part is the 5% of the effort, right? What you need to work on is things like getting the data in, how do you do feature extraction, how to verify that you have right data, follow all the security and safety protocols, how do you manage your compute, how do you serve your models, right? That was a big thing. There's a big box in there. How do you do monitoring and so on? So essentially, think about that as a regular software platform, but now this has to actually do machine learning, and it brings more problems to the table. And I think personally, I think there has been a lot of work in the recent years to tackle those. For example, this year to me in the community is very much about serving models. I mean, we heard today about serving NLP, and a lot of the players across the board are focusing on facilitating very easy serving, so you don't have to worry as a data scientist how your model gets to production, which historically has been a major problem, because it takes an engineering team to do that, which is not what you want necessarily if you want to iterate quickly. So this is changing, right? And I think we will see a lot in the coming years. This change will be more and more efficient, and we will see more and more tools which essentially fit our process of delivering AI, delivering ML. But there's a second side to this coin, right? And the user, right? I think, and this is one thing we typically overlook, I think, and this is why I'm actually emphasizing through this talk a lot of these aspects, essentially. So my personal perspective on that is when you think about a user trying to use an AI system, there is a lot of expectation there. There's a bit different expectations than you would see if you think about a regular software system, right? And there are various reasons for that. One of them is that in some use cases, like conversational systems, you think about this expectation of general intelligence. I mean, we expect these bots or these dialogue engines to, we can communicate with them like normally using normal language. For example, Siri is getting better, but it's not there. There was a bit of a hype around chatbots. I think it went to a small chatbot winter a year ago or so. Now it's coming back up because people realize it's not about general intelligence, it's more about narrow intelligence, where you can actually do one simple task very, very well, and that's what AI is really good at the moment. Second important factor is the error scenarios. I mean, if you think about ideal agent or AI system, you don't see it running. It does things in the background. I mean, your spam filter, you don't see it telling you every time you get a spam email saying, hey, I got some spam. It just tells you sometimes that there is some email that doesn't know what to do. But it also means that if something goes really, really wrong, we immediately see that, and we have a very, very bad perception of that. And there are examples of that. For example, I don't know if you heard the story about Microsoft releasing a Twitter bot called Tai, I think, some time ago, which people very quickly turned into a very nasty racist bot. And through data manipulation, and this is also an interesting aspect of what's happening now in AI domain, that now you also need to think about how you can manipulate those algorithms through giving it specific data, right? So something that people haven't thought about before, AI, because you can actually impact results of what AI does based on the data you give it for training. Third one is the lack of understanding how this really works. And there was this idea in the past that we can just give people a black box and call it AI. And it will magically work. But very quickly, there is this issue that you don't want to hand off the important task to that box. For example, routing. You would assume that routing in a call center can be automated 100%. But there is still this element that in some cases there's lack of trust, and you have to go through a very specific, slow process of deploying for a subset of agents, and giving a lot of explanations what actually happening under the hood, which again limits the algorithms you can use and so on. So there's limited trust in some cases, right? And of course you can argue, and I will argue this as well, depends on the domain. I don't really care what Spotify does under the hood. I love Spotify as a product. I think they do a great job. And I'm happy to trust it with recommending the music to me, right? But in some domains this is very tricky. And also it brings the strong need for control in some cases. And my favorite example here is self-driving cars, right? And I'll have an example about that in a second. So about general versus narrow intelligence, I think we all speak about general AI. I know Elon Musk and a couple of other guys are alarming us about those visions of issues with AI, and it's definitely there are good reasons to look into that. But there was a survey recently, well, 2013, not so recently because a lot has changed since then, about when do we expect, when AI domain expects the general AI to come out. And optimistically, so very unlikely, it's in a few years. So that's a bit scary, that's true. But 2040 is the most likely scenario. So we still have a couple of decades before we get there. And a couple of things have to happen before we are able to actually talk about general AI. So from my perspective, I like to talk about this through the lens of agents. And there's this book I recommend you guys about designing agentic technology. Is essentially how you can focus AI around human needs and tasks and all that. And so I took inspiration from that book to give you a couple of bullets here essentially. And think about agents or AI, or narrow AI as something that does work that you are not good at. For example, autopilot. People are very bad at boring tasks. There was an interesting experiment a few decades ago, where one researcher put, I think, 60 people in front of a clock, and that would just show seconds. And every whatever minutes, it would skip 2 seconds instead of 1. And he asked people to identify those moments. And he asked them to do it for like 2 hours or something, right? So he very quickly realized that your threshold is half an hour. After half an hour, you just are not able to pick up those clues, right? And if you think about an autopilot that needs to fly a plane for 8 hours, that's a problem, right? Because that's why you need the autopilot, essentially. There are things that you're unwilling to do. There were applications of AI. For example, I think it was Brazil where they deployed a system that would detect shots fired, because they found out that people heard shots, but they were afraid to call the police because they were afraid of retaliation from the gangs. So then instead of that, they put a system in place that would, call the police in case a shot was fired. So it's very interesting. And then, think about false positives, false negatives in that perspective, what happens then. And there's a lot more, right? There are embarrassing things we don't want to do, and AI can help with us. And there's always this, conversation about automate versus enable. So automation is what we are all afraid of, that we will lose jobs. Like I was really afraid today that I would lose my job when I saw this presentation about automating model training, to be very honest with you. But I think we should think about this as enabling us to do other things. And one of the examples I liked a lot from this book as well was drift. So we heard about IBM Watson a lot. What drift essentially is that you have some preferences in your mind, you have some view of the world, and then you start drifting that set of preferences or or things you can do based on AI, or in this case. So, IBM Watson can provide you with recipes based on the ingredients you give it. If you don't have something, it will try to come up with a new recipe. So I found this article online, which essentially listed a couple of interesting ones that IBM Watson came up with. Interesting, for example, crow, shrimp, lamb dumpling, which seems to combine some Asian or maybe Polish, because it's a dumpling, with other cuisines and so on. So this is something that AI enables us to do. We would never think of doing that, or very rarely would think of doing that, and that's kind of interesting. The question I had in my mind there then was, should we blame the user because they do that, or it's part of the blame is actually on us, because historically, now it's a bit different, but historically, like I know myself, I'd love to build algorithms. I wasn't thinking about how or what it does for the user in the end. Data science teams typically would be, an ivory tower, essentially detached from the customer in production, because the lack of tools as well, right? So it's the process that we have to think about here. But also access to meaningful data. I've seen all the time when there were small teams around the company doing research with the data they had. It was very difficult to actually combine that, and in some cases even get access to meaningful data in the first place. Then there's this issue of getting proper feedback and measuring what your model does to the user on the production environment. And actually, it's harder in some cases than you would think, I think. And to close that part off, the metaphor I liked a lot was the way we should think about building AI products is, think about asking a 5-year-old to do the dishes for you. I mean, you have to do a lot of hand-holding to make that happen. So this is how AI at the moment works. You need to give a lot of examples. Don't expect too much, So if I were to sum up a takeaway from what I would like you to get out of this talk, it's a couple of things. Right? Keep customer or the human, let's say, in the center of what you're doing. And human-centered design or design thinking are techniques you can actually use to do that. I will show you a bit of that in a second. When you're building a product that uses AI or ML, I always like to think about what's the experience in the end. So what it does for the customer, how he or she would interact with it, how you would handle errors, how you would provide any explanation of what's happening under the hood, and also how you would give control to the customer, to the end user, and how you would get it back when the bot or agent is ready to do that. And I'll give you some examples of various cases here. So, I just Googled human-centered design images, and this came up, essentially. So when you think about it, the bottom line is very simple. You need to figure out what problem you are solving for the user, for the human. And if you are able to do that, then there are a set of techniques you can actually employ to help build a system that solves them. And I like this initiative from Google, that essentially they recognize that as well, and they say, well, we had a lot of UX research at Google, but what we recently started doing is to look into how we can employ human-centric design, essentially, and design thinking in designing those products that actually help humans, right? And I think a good example we saw today in the morning was the Google Translate, not the Google Translate, but the earbuds that can do translation for you in real time, which I think is awesome, solves a lot of problems for some people. I can see me myself using that. And because if you don't do that, essentially what will happen is that you will solve a problem maybe nobody cares about. You will put millions of dollars of infrastructure in place, and spend a lot of brain power to do something which maybe is interesting, but perhaps not really relevant. So in design thinking, it's very simple when you think about it. You first need to understand your customer. And there are these phases of empathize and define. Have you ever seen that? I don't know. Then there is the exploration, which is essentially let's try things out and see what happens. And then only then you actually build the product. And I always smile when I see that, because my first attempt to build a product doing AI was simple in principle, but it took me almost a year and my team almost a year to come up with something, because of all these other problems in terms of infrastructure and so on. And in the end, we changed a lot in our process, and now we can iterate. In a few weeks, we can actually push something out to the customer and get feedback and actually solve better problems with that. Reality is not really a circle. It's more a fully connected graph, let's call it in the data science language. Essentially, you need to revisit a lot what you're doing and how you can do that. So that's something to keep in mind. But when you think about this data science work that we do, and how to map it to the design thinking process, let's say, because remember, this comes from the core UX research that would deal with non-AI products. But I've seen a lot of teams apply that internally. So when you can think of a customer as some other team in your organization, for example, that works pretty well, and you can start actually delivering some results quickly and then get their feedback if you're building a tool, for example, to do some data science or deploy models and so on. So you need to understand them first, right? And what we typically do in those scenarios, first we say, okay, what do we actually need? What's the problem they are facing, right? Why? How can we bring value to what they're doing? And what are the bottlenecks, right? For example, is it that they spend so many hours coding, deploying their model to production because they need to write code? What happens if we automate that? Or what would be the cost of automating that, whether, across or against the cost of actually them doing it, and so on? Because that allows you to define the problem in more specific terms, and typically the key there is to come up with good metrics as well. How can you do that? And that's something I know that we are used to doing in research. But then, sometimes I think myself, I'm guilty of that, that we fail to translate that into actual product development, really. So explorations, the way I like to think about it, there are plenty of tools out there as well to, for example, grab some data, put it, spin up Jupyter Notebook, or, there are tools, notebooks especially are very nice to do that. Get some data from, I don't know, database or S3, run a couple of models, visualize that, go to the customer and say, hey, this is actually what we came up with. It looks pretty interesting. We can show value. What do you think? Do you want to be an early adopter? Can we try something out? And so on. And you can iterate this circle without actually writing production code at all. And I think this is a necessary step in many cases. In some cases, maybe not possible, of course, but prototyping is extremely important. And it will help you understand the issues with your thinking much sooner, and it will be much cheaper to do it that way in the long run. And then you have materialization phase where you build a solution. So that's where the production ready code happens at scale and all of that, right? So that's I think just a simple example of how this process could look for data science teams and, say, ML work. So in the second half, I'll just give you some examples for these considerations I outlined. So essentially, when you think about user experience, what are good examples of products, bad examples of products, how to approach different use cases, different perspective. Looking at user experience, looking at how do you provide feedback to the system, how can you do explanations, how can you manage who has control and how. And how you handle errors, right? So, one example comes to my mind very quickly is Nest. Have you heard about Nest? Yeah, okay, some of you heard, right? So this is essentially a smart thermostat, right? So what's cool about that, I always have this problem. I travel a lot and I leave my heating on in the house, right? So what happens then is I burn a lot of oil or gas, which is not necessary. There are different, weather is different. One day can be 25 degrees centigrade, maybe one day is 5, at night it's colder, and so on. So, currently, let's say, or historically, we would have to adjust those settings manually. We would also, every time weather changes, we would need to go and do something with it. So the promise of Nest is essentially it has access to other data sources like weather forecasts. Potentially it can access your location, so it knows that you are traveling somewhere, maybe shut down the heating and so on. So it solves the real problem of optimizing heating in your house. Simple interface, it's not much to actually set and do there, which I think is the experience of it, and it feels nice. It's pretty nice. And also it gives Google a lot of data about our patterns, so it's very, very cool. Feedback. So I mentioned earlier, I'm a big fan of Spotify. It solved, I used to use other services before, but solved the music problem for me because I like discovering music. I like listening to music and all that. So Spotify did a couple of things right, I guess. So one of them was the feedback mechanism. In the past, it used to be thumbs up, thumbs down. You hear a song, thumbs up, you get more like that. Thumbs up, you get less liked it. But there's also tons of features they generate based on your behavior. Like, have you listened to the whole song? Have you skipped? What sort of navigation and searches have you performed, and so on. So, there are multiple ways we can go about that. Which, in the system, which is a software system, there are some limitations, but, I think we can always think about explicit versus implicit feedback that we can feed back to our models to do stuff with. I like a lot the one by Tesla. So, if you go into the physical world, which, it already has happened, we all interact with our Roombas, and hopefully one day we all have a Tesla to drive. But one cool feature I read they have is that if you don't like the way Tesla handled a corner, driving autonomously, you can go back and actually teach it how you would like it to do that, right? So you can take the corner a couple of times yourself, and then this is the way to provide feedback to the car to adjust the model, right? And another cool idea is, you have vacuum cleaners which essentially have embedded algorithms to clean up the surface. What happens if you move the carpet, right? I mean, you could just move it to the carpet a couple of times, and it should pick up that there's a carpet there. It should put more attention to, hoovering that particular area in there. But also, like when you move to explanations, there's various levels of explanations you can give, and it all depends on the use case. Again, Spotify, they don't give me any explanation on why I got these recommended lists of songs. And actually, the truth is that they do something really smart there, because apparently those daily mixes, they actually come from other users mainly. So, they crowdsource a lot of this information. They get your tastes and then say, oh, there's somebody with similar tastes with that list, so let's just do that. But actually, it works pretty well. I mean, you can clearly tell that I like jazz, I like Polish music, and I have a baby, because there's plenty of Misha and Małgosia and other baby songs out there, which I put on in the car sometimes for my 2-year-old. So that works very well, and to be honest, I don't really need to know why they recommended this particular artist to me. I mean, just the cost of error is very low there. The basic example I always give of explanation was coming from Amazon many years ago. People who bought this also bought that, and typically it's collaborative filtering underneath, but I don't really want to know or have to know what algorithm they used. It's more about, aha, so if somebody bought that, I should look at this. Sounds clear to me. I'll have a look at these books and so on, right? So that's a very basic example. There is also a bad example. So I love Netflix as well. I think they're doing very interesting work in terms of platform and tooling and the actual core AI work. But they changed interface quite recently, I think. So in the past, when they would give me recommendations, because it's all powered by recommendations here, right? They used to give me movie rating. So I would say, oh, these are the 5 movies that you should watch, and here are their ratings. So then very quickly, so that was my use case. Very quickly, I would look at them and say, this is a very poor rating. I don't want to watch that movie, right? Because obviously they are all in the same category. And then it was very easy for me. Now they give me match, right? 98% match. So what does it really mean? Like, how is it better than 92% match? Should I not watch the movie which is 75% match? Or what should I do with that, right? So it's okay, it's cool, and probably some product owner had a brilliant idea there to say, let's externalize our scoring mechanisms there. But to be honest, as a user, I feel it's a downgrade, right? I don't really see the value of it, and that's an example of something that probably took some engineering to get done, but doesn't really bring value to me as a user. And Tesla again, right? Let's talk about control for a second. That's a pretty interesting one, because in some cases, control is, you need the control to actually help the algorithm or to influence what happens under the hood. But in this case, it's very different, because in this case, what we're talking about is that you're driving a car, or the car drives itself rather, but you have the wheel to take the control, right? So essentially, you as a user are capable of saying, okay, that's it, I'm taking the wheel and now I'm driving the car. And on one hand, it brings a series of interesting considerations, right? Because if your Tesla works really well and you haven't been touching your wheel for 6 months, and now it suddenly hits water and starts sliding, will you be able to actually pick up the wheel and recover the car? I mean, probably not, because you haven't been doing this for 6 months, right? So that's an interesting consideration as well when you design those systems. Like, should you embed, for example, training programs that every now and then the Tesla will ask you to actually drive the car? That's one. But more interestingly, Google decided to go the other way, right? They have no wheel. So I didn't put the video in, but there is a very cool video of people trying the Google car for the first time, and none of them look calm, right? So they all look very scared because they go in the car and there's no wheel and the car starts moving, and they say, oh yeah, the car is fantastic, it stopped when it's supposed to, but there's no wheel, right? So I had a similar experience back because I live in Ireland, and I had a Polish car with a wheel on the right side, right? And once I got a friend who was an Irish driver, he got with me in the car and there was no wheel, and the car started moving, and he freaked out. He left the car essentially because he couldn't take it. So this is a similar experience, right? What happens if like one example I like there, what happens if the sensor breaks and there is no laser sensors anymore? Would you stop the car? I mean, what would you do next? Would you expect the car to talk to other cars and then do the herd and drive together? Or like, how do you get home, for example, right? So these are the considerations we never think of, but I think are interesting and relevant, really, right? Because in the end, this is how we show value to the customers or the end users of our machine learning software. And another one, which I think relates to the stock market, let's say, it's Robo advisors, right? So I don't know if you're familiar what Robo advisors are. Anybody? Few, right? So essentially, in short, if you want to, if you have some money to invest and you don't want to do it yourself, you can give it to machine to invest. What typically happens, you go through some tests. They, let's say, build your risk score and propose a portfolio, and they start trading your, in short, trading your money. Now, question of control is very interesting here, right? Because when you look at what people do as investors, when the market crashes and they start losing money, they want to bail out. They want their money back and they start selling, right? But technically, it's not always the best moment to do that, right? So the question is, should the agent give the control to the investor back and allow them to manipulate their own money? Or should they just say, look, I know what I'm doing. I know you're panicking, freaking out, but trust me, I can get you the money, right? So interesting perspective, and I haven't thought about it, but it really depends on the use case. And last few slides, really, because I think I'm slowly running out of time. That's what I told you about regarding the Microsoft bot, so Tai, right? It's key. Currently, errors will happen. There is no system of 100% accuracy or F-score. False positives or false negatives will happen. The question is how to handle those gracefully enough so that the user doesn't see that or doesn't have a bad impression or doesn't impact the task the user is doing. One example, which I think is pretty straightforward, there is this bot, which essentially in 24 hours went from very nice and polite bot to a very nasty and bad behaved bot. So how do you so for example, what could you do there? You could think of there should be some fail-safe mechanism, right? I mean, you embed fail-safes in a lot of these tools, like routing mechanisms for call centers have fail-safes. If something bad happens, the AI would say, okay, I don't know what to do. There is some set of rules that some human defined, and we just go to that. And in the meantime, we have to figure out what's going on, right? So designing those mechanisms in some cases is extremely important because the cost of error is actually very different in those domains. Like I mentioned to you, in Spotify, if errors happen, I just skip the song, right? If Tesla runs into the tree, it's a big problem, right? So how do you deal with that? If I ask Siri about something and it comes back with something completely different, it's maybe funny. I don't really mind. But if we route a customer to a bad agent or an agent that's not suitable, for example, doesn't speak the language, I mean, the cost of that is pretty high because the user gets even angry and we lose money essentially. So things like that are important. And the reason I went from technical talk and talking about tools and algorithms and all that to this is I just feel it's important for the next decade or so to more and more think about those. How are we designing the experience around our products that utilize AI and ML? And how can we essentially bring a lot of value to the customers? So whenever you think about, that's my takeaway for you guys. Whenever you think about, oh, I have this amazing algorithm that does so many amazing things. Think about how you can use it to, help the users. How you would design experience about that. How you would get feedback from the user. How you provide explanations. How you would think about control management. And definitely, how would you handle errors in those scenarios? And I was allowed to put the slide up. We are hiring. So if you think about joining a team that works on a lot of cool AI in the product setting, go to the website or just give me a shout. We are based in Galway in Ireland. So it's a pretty fun place. It has amazing weather. Grzegorz can testify to that. So that's it, really. Thank you very much. And I'm happy to take some questions.
So thank you very much. We have the first person to ask a question.
Hey, thanks. I really like your talk. It was really engaging.
Thanks.
How would you react to backlash from people who say that self-driving cars, for example, are bad because, look, somebody died, but we consider the fact that, statistically speaking, they're way safer because we don't have stupid drunk people on the road?
Yeah. There is no easy answer to this question, right? Because now it's one thing I didn't really mention, but now we are into ethical considerations, right? And this is the common thing that the self-driving cars or the manufacturers have to deal with. Those scenarios when the car can hit the tree and maybe potentially kill the driver, or safely go to the sidewalk and kill 4 pedestrians, for example, right? And I don't think we have an answer to that, right? And I mean, the only way I would think about that, which is very far-fetched, I think is once you arrived somewhere closer to general AI, you could start thinking about trusting it enough to take a good decision. But the problem of that approach, which I think in our life we won't get there, is that there is always a limited view of the world for any algorithm. I mean, we have a bit different perspective on the world and access to long-term memory and patterns and so on. Like AI wouldn't know that by hitting this particular spot in the wall, it will actually destroy some power device which will kill electricity in a hospital and kill 50 people because of that, right? So I don't have an answer to that. I think it's a very important thing to think about. I don't think anybody has an answer to that. So.
Hi, I have a question. What is your advice to somebody who's an advocate for AI and machine learning inside his or her organization? I mean, what is your advice to somebody who wants to explain in plain business terms something about AI and machine learning to product owners and product managers? But I am myself a technical person. I sometimes struggle with that to just show the business value behind AI, and maybe you could give some advice to people like me.
Yeah, so it's a hard problem, and I've seen this a lot actually. So what we have tried, and so far, a couple of things you can try, but some of them actually work pretty well, is first of all, I think baby steps. So I once tried to build a product, full-fledged product, and it took a lot of buy-in, and it worked, but it was late. I think what's important is to take a data set without anybody really, any big fuss around it. Take a small data set, find a use case, spend a week or 2 with some AI people doing some POC and saying, look, we can demonstrate based on a simple experiment, we can create this business value, because that's really the key, right? Business value and what you can do with that. Because that typically opens the door and allows you to think about getting more resources and actually seeing value in there, right? So from my perspective or my experience, it's not so much about technology. Nobody cares if you're using deep learning or not, really, right? I mean, let me take that back. People do care because they want to say that, oh, we're using deep learning, right? So because they are keyword compliant. But I think the trick to move forward is not that, is actually showing simple steps towards value and how you can get there. Because one thing that people fail to do is they run a small experiment sometimes and they get good results. But then they fail to have a plan, how to build a product around that in the next 6 to 12 months, taking 20 people on board and so on. Right? There's a gap there, right? So there are important steps on the path as well. I don't know if it helps you, but cool. Okay, any more questions? One more there, yeah.
And there's a couple more.
I have the question. We have our working project with simple reports already, and we decided that we want to use AI. But what's the biggest problem to face when going from simple reports with clicks and distributions to predictive machine learning? What are the steps you have to take to go from 0 to hero?
Let me go back a few slides. No, I mean, plenty, right? Because, and I think I will repeat maybe a bit of this answer, right? The first thing you need to figure out is what you want to achieve with that, right? Why do you want to build a predictive model? I mean, what's the use case? I mean, how you can get value out of it. Like in our case, it was very simple in a way because in our platform, we had a way to enact the prediction. So essentially, if my model predicts something, I can actually offer a chat or give a content offer to somebody. But that's not really common. So the first question is, what do you want your predictive model to do? Is it predicting churn or is it predicting something, right? And then I think it's the framing, getting the right people. I think Anthony actually mentioned a couple of things in the morning that you need to have the skill set spread. You need somebody from the business side to understand the business. I think the biggest bottleneck, to be honest, is getting access to data very often, but sounds like you have the data, so that's awesome. You know, get somebody to prototype something for you in a week, and from there you can see what's the potential, you can frame the use case, and go forward, I think. But it really depends where you want to get to in the long run, right? Because the bottlenecks you typically have or the issues you have is, you know, first of all, how you get the data, then how do you convince the people, then how do you actually get to production with it? I mean, and the question is, do you need to get to production at all? Because maybe providing some, you know, offline predictions is enough. In many cases, it is enough. Yeah, thank you. Okay.
Okay, thank you very much. Cool. Sounds like it's
Thank
all
you.
the questions.
Yeah.
Thank you.